CP? First of all, our entire agenda, our motto is that it is fun. Okay, when you sit down, I guess this is a feeling almost every one of you must have had up until now. When you've written a piece of code, it's a kind of a long code, something. I don't know how many of you are white coders here, but if you've written anything on your own entirely and you've run it for a project or anything in the lab per se, you feel a small amount of happiness or a bit of acknowledgement in your inside you. You feel a bit happiness. కొంచెం మంచిగా అనిపిస్తుంది మన కోడ్ రన్ అయితే, compared to getting errors and not getting executed or your functionality not being implemented correctly. You feel a bit happy when whatever you've written works perfectly fine. So that excitement is what we chase here. Every time there's a contest and there is a problem and you solve that problem in under 10 minutes or 15 minutes, it looks very complex, but you're able to solve it and you write your algorithmic code, and when you run that contest or when you run for the answer for that problem and it clears all the test cases, we get a huge kick out of it. I guess my fellow peers who do CP or all of you guys who've given a contest at least once should have experienced that. When you write your solution and when you hit that run button and all your test cases are passing, you feel a kind of thrill. Okay, ఇప్పుడు అవుతుందా లేదా, are all my test cases gonna pass or not? Then when you click that submit button, especially in CodeChef, you see that yes, all test cases passed and you're done with the solution. That moment when you see that, you feel happy. You feel excited. Oh my God, what is this? I'm able to do this. This is fun. This seems interesting. I guess at least at some point, you guys must have had that feeling, right? I do have it a lot whenever I give contests. So do our people. So we like to chase that thrill. We like to get that dopamine kick. That's why we feel competitive programming is something that's really fun. And we want to do it. And we want our juniors to do it. And we want to build a huge community of people who are doing it. So I hope you guys feel that thrill, and that's what we chase. But besides that, what other benefits we might have? First thing is that when you do CP, it increases your logical thinking and problem solving ability by a lot. If I guess a lot of you in this ChatGPT era, whenever you see a problem statement, you might be using GPT to get a solution or approaches. You basically have stopped thinking, I would say, because when our seniors were here and we were here, ChatGPT was not that advanced. We were not that reliant on ChatGPT, but the coming generations are becoming reliant on ChatGPT. So that is one thing we would suggest you guys to avoid. You lose your problem solving and logical thinking abilities. That is something you will never get back again. And by doing CP, you essentially rewire your brain. I'm saying this out loud and you can quote me anywhere. You rewire your brain to optimally solve problems faster than ever. You do this really. See, at the end of the day, I guess all of you here seek a job, right? At any point. Be it most of you might be computer science engineers, you would be going for a software engineer role. There, you will have to solve industry level problems, which are real problems in this real society. And there, the most important thing you will have is not your resume or not the amount of skills or amount of technologies you've known. Only thing there would matter is your problem solving skills. Am I able to solve the problem that is presented to me? So if you're doing CP, you have an enhanced problem solving experience, an enhanced logical thinking experience, an enhanced potential for optimization, and an enhanced ability to solve problems much faster, and you get to the solutions more quicker. Basically, problem solving feels intuitive for you. Your job becomes a whole lot easier, right? Your job becomes a whole lot easier and it becomes a lot fun. If you're good at solving problems, that will essentially weigh in a lot for you going in future career. మీరు వెళ్తున్నప్పుడు చాలా చాలా ఉపయోగపడుతుంది. It's not just in computer science, not just in software. A problem solving and logical thinking ability is useful anywhere you go, anything you do, it will be useful. So that is one of the other main benefits you get out of doing CP. You build really good problem solving skills, you build really good logical thinking and optimization skills, and your brain essentially gets rewired to look at every problem and think of a solution really fast. It might not be the most optimal, it might not be the correct, but you take a take your first step towards solving that thing. So that is something you can do, get out of doing CP. And for those of you aspiring software engineers, doing CP helps you get landed good jobs. That is there, because a lot of people who are extremely good at CP, they frequently land jobs in Mang companies. I don't know whether you guys know what the term Mang is. Mang is basically Meta, Apple, and Google, Microsoft, Netflix, Amazon. These all companies come under Mang, and they offer ridiculously large packages even for freshers. So if you are completely a placement oriented person, doing CP is going to help you a lot there also. So at the end, what I would like to conclude is CP is really fun, and you don't lose anything by doing it. Or at least I would suggest every one of you try out doing CP, because there is nothing to lose here. You'll have a lot of fun. You can do a lot of learning. You can get into some stuff. You can explore yourself. You will understand yourself better, where you stand, where you have to improve, where you're lacking. All of these things will teach you a lot. So it's good. Try it out, have fun, enjoy a little. You need guidance. During it is here with open arms, ready to help, do whatever we can, whenever we can, however we can. So get into it and learn CP is what we would suggest. And that's it about CP, and why it's so fun, and why it is something you should probably try to pursue. We wouldn't force anyone, but again, it is very interesting and it is very fun. Believe me, as a third year in my 3 years of college, one of the most fun things it has been is to give contest, especially that Codeforces Div 2 contest, which is every day, which is there every week, once or twice. It is so fun to give. So you can just build on it. It will help you wherever you go, however you go, and whatever you're doing in life, you'll have some use, some help, and it's a lot of fun to do. And now we will be going ahead with the coding platforms, where you can actually experience competitive programming, where you can give contests, and where you can have that feel, or where you can learn. Okay, over to Shailesh. Shailesh?
Yes, I'm Shailesh, currently in third year AML. So there are many platforms for CP like CodeChef, Codeforces, at Coder. We'll begin with CodeChef. Ankit, please drop your screen.
Okay.
So yep, let's start with CodeChef. For beginners, I would suggest CodeChef is the best platform to begin with in CP. So when you go to CodeChef platform, uh, if you have account, you can log in, or else you can just sign up with your Gmail or something. So this is the interface you get when you log in. So this is what CodeChef is. In the practice section, you'll have different problems from past contests. So rather than this new UI of practice, we'll go with old practice page where we can sort problems based on difficulty level and on different topics. You can select the difficulty rating here and also topics here, whichever you need to practice. Initially, I selected 0 to 1000. So you can have different problems here. Let's say we'll go with any sample problem where we can run and submit that to show you all the interface of a problem statement in CP. So I have opened this problem called caps, the cheaper cap. So you see this left side panel is the problem statement. So this is the title of the problem and the description of the problem statement is given over here. Uh, this is the input format and output format. I'll go with starting after explaining all the formats here. So then you have constraints of the variables mentioned in the problem statement. And there are some sample input and outputs along with explanations given over here. So on the right side, you have a compiler provided by default and CodeChef. You won't get this compiler in Codeforces or at Coder. So in the problem statement, they'll explain all the variables and the scenario for which you need to code. Let's say, let's read this question. So chef has to travel to another place. For that, he has two options. First cab service charges X rupees, and the second one charges Y rupees. So the chef wants to spend minimum amount of money. Which cab should chef take? So whichever is cheaper, we need to print that. So he'll give the input format. For there are multiple test cases here. So there is T input. So this is a single test. In this test, there are multiple test cases. See, there is three here. So three indicates here the number of test cases. And for each test case, the input format is mentioned over here. The first and only line of each test case contains two integers x and y, which are space separated generally. The prices of first cab and the second cab services respectively. Fine. So what we need to do here, we can take the input of x and y, and if x is less than y, we can print first, or else if y is less than x, we can print second. If both are same, we can print any. So the output format, whichever is specified over here, we need to follow that. So it is clearly written for each test case: output first if the first cab service is cheaper, output second if second is cheaper, or else any. So yep. These are the constraints over here. While I already said T indicates the number of test cases, so it's between 1 and 100. So the value may vary between 1 and 100, and XY values are between 1 and 100. So this is only a sample test. You have multiple tests. When I submit, the multiple tests get run, and you get the output of it. Let's say we'll go with C first because most of you know C language here. First, I will take the input of the number of test cases as specified in the input format. So I'll just declare a variable T, and I took the input of T. So what I need to do here is, for each test case, I need to take the input of X and Y. So I need to run a loop basically. So let's go for int I equals to 1, I less than equals to T, I plus plus. So this is just running a loop from 1 to T. So in each test case, I'll take two inputs of integers X and Y. So let me just declare these values. So when I took the input, you can just write the code over here. If suppose X is less than Y, what we need to print? First, printf first. Else if suppose the second one is lesser than first one, I can just print second. Else I can print any. So I just took the input of number of test cases first, and I run a loop from 1 to T, where each iteration indicates a test case. So I took input of two integers X and Y, thus the fares of two caps respectively. So if X is less than Y, I printed first and second and any as specified in the output format. So this sample input is by default available here in the right side panel. So when you run it, your code gets run for the sample input. So we can see this output here, your output and this expected output. So what I did here is I didn't put new line over here, but in the output format, he specified that for each test case output first, uh, it's specified in the sample input. We can see here. So everything is in the new line. So I'll just add new line here. So let me run again. So yep, we got the expected output as same. So I'll submit it. So what happens if we submit is there are multiple hidden test cases available. So our code will be run against them and we get the verdict of it. We got correct answer, which is AC, accepted. I'll just try to submit a wrong answer. I'll remove new line over here. Or let's say I'll put extra T over here and do submit. So we got failed on a hidden test case. Many so if one test case get failed, the further test cases are skipped here. So this is a wrong answer worded. And there are many other like TLE, memory limit exceeded, runtime error, etc., which you eventually get into when you solve problems. Instead of a for loop, you can also use a while loop over here. See, we are not using the value of I in the no in the loop, so we can just run the loop t times by putting while t minus minus. So each time it gets decreases, and after t times it gets zero, which is false. So it gets exited from the loop. You get the same output. Yep. So when you solve a problem, if you don't get it, you can check the submissions or editorial of others. You can view over here, view all submissions. You can select a language, status. Contest is not really necessary. So you can dive through these solutions and understand them. Or else we also have editorial section, which is available in CodeChef Discuss. You can also take pro subscription, which is not really recommended to take. Uh, we have editorial for every problem in the CodeChef at CodeChef Discuss. When you search CodeChef Discuss, you will get a URL discuss.codechef.com. So everything about CodeChef, what's going on in CodeChef, contests, announcements of contests, editorials of different contests are provided over here. So when you log in, you have different categories over here. So we'll go with editorial section for now. You can explore the remaining sections at your leisure. So our problem statement is, you can see here it's caps in the URL. So it's like code, like a sample code for that problem. So when you search for that, caps in editorial, so everything, the details of the problem statement along with the editorial approach and solution are given over here. So difficulty is cakewalk, problem is mentioned over here. Explanation is given for the solution. This is simple, so the explanation is very simple, or else it will be bigger to understand. And time complexity is also given, big of 1 for each test case, which the time complexity will be discussed in the next part. So you can also check the solutions over here, editorial solution. These are not working, like these are old contest problems. but you get it. I'll go with the latest one. So when you check this, there are prerequisites, problem statement, explanation of the solution by the editorialist, and time complexity mentioned along with the code. So you get editorial of every question in CodeChef at discuss.codechef.com. You can just search in the Google CodeChef discuss. So I'll also write the code in C++ because in CP most people use C++ because of its lower runtime than Python or Java or something else. And coming to C, the disadvantage is that you don't have many inbuilt functions, libraries provided in C, but C++ has it. So it's similar to C in many aspects except the print and the input statements and header files. So similar to C, the header file here mostly used is bits std c++.h, which is a universal header file in which every header is present, including math, algorithms, utility, vector, string, maps, etc. So you can just include this header file and code it out using namespace std. So if you want to explore C++ language, you can go with the language specific videos on YouTube or some other platform. So in the same way, I'll add the code. I'll declare a variable t, and this is the input taking input in C++, C in, which means console in, and I'll run a loop for t times. For each test case, I'll take the input of x and y. So if x is less than y, I'll print first. Else if y is less than x, I'll print second. So the printing format in C++ is C out, which means console out. Else I'll print any. I'll just run it. Bits slash std c++ dot using namespace std. Okay, includes playing strong here. So this is the output, and when I submit, you get correct answer. So we'll go with contest page in CodeChef. So this is practice page. I recommend you to go with the practice old page, which is the option is available here. Old practice page. You can select the difficulty range over here and the topics whichever you want to practice over here, and you can sort the difficulty wise problems and you can solve these problems. When you go to complete section, you have different contests mentioned over here. See, we can see the past contests. So in CodeChef, generally there's a contest every Wednesday from 8 to 10. If that's rated for all or it's something like a difficult contest, they give more time, like 2.5 hours, which they give on second. So these contests are called starter contests. So we are in the 193rd edition this week. So next week you get starters 194, which is mentioned in upcoming contest with the time 8 p.m. from Wednesday 8 p.m. to 10 p.m. Let me open a contest. So this is the contest interface. So generally your rating begins with 0 if you just sign up into your account. So we'll be going into Div 4 by default, which is for less than 1400. So you have different problems here, which are generally sorted with difficulty level. You can open a question and read problem statement, the input format specified, the output format, the constraints, and you can write your code over here either in C, C++, Java, Python. The options are provided over here. You can run it and submit, and you can move to next question if that gets easy or no, you don't get that solution or something. And you can see the ranks over here. These ranks are based on the time and accuracy you solve. Like if you solve three problems and your friend also solved three problems, but your friend solved 1 minute faster or earlier than you, so he's placed in the rank list above you. So we have 16,200 people in Div 4 only. So we have other divisions also, which are Div 3, Div 2, Div 1, which will eventually get into. So when you go to Provel, you will have your username. So when somebody asks your username for contest, you can give this just username. You can edit it also, and the all the contests you participated or mentioned over here, and the total number of problems solved by you, and recent submissions or activities are here. You can move to next page or something like that. We'll go with next platform, which is Codeforces. So in the beginning, uh, just open an account in CodeChef and go to practice section and go to old practice page, sort it from 0 to 1000 and sort by difficulty and go on solving these problems. When you get comfortable, like you like when it seems like these problems are very much easier, you can skip difficulty rating and skip to 200, 300, 400, and you'll get to 1000 like that. So after solving only practice problems for about 10 days, you can give starting contest on Wednesday every week in the complete page. So everyone start contest at 8 p.m. only, because even if you start at 9 p.m., it will consider that you started at 8 and solving question after 1 hour. So everyone started 8 p.m. only. So we'll go with code forces, and also forgot to mention the divisions in CodeChef. So up to 1400, division 4, then 1400 to 1599, it's division 3, then 1600 to 1799, it's sorry 1600 to 2000, it's division 2, and above 2000 it's division 1. You can update your college also in institution in settings page, I guess. You can explore it. So we'll go to Codeforces, which is the heart of CP, which is the main coding platform where everyone in the world does CP here. So when you go to Codeforces, if you don't have an account, do register with Gmail or something. I'll log in into it. Are everyone following me? Did you get everything in CodeChef? How to solve problems, problem statements, how to sort problems on difficulty, topic wise. So I expect everyone to give contest next week or the next one when you come to college. So yep, we'll go with Codeforces. This is the home interface in Codeforces. These are all the blocks, like the whatever is going on now in the currently, you'll get all the updates in the different blocks. So when you go to contest page here, there are different past contests you can look over them. So there are divisions in Codeforces also, like CodeChef. So for Div 4, it's up to 1400, and for Div 3, it's up to 1400 to 1600. But you get rated uh, if you are less than 1600, and for div 2 it's less than 1900, and for div 1 everyone will participate in it. For div 2 it's till 2099. There are different levels in Codeforces, which start from newbie, pupil, specialist, expert, candidate master, master, international master, grandmaster, and at last you have a legendary grandmaster. So in the contest phase, there are many past contests. You can, let's say I'll go with any Dev 4 contest. You can start the divisions over here. It's a Dev 4, which is basic one. So all the Dev 4 contests in the past are here. So this is the contest page in Codeforces. It's similar to CodeChef. So there are many problem statements over here. I'll go with one. I don't submit now because we don't have much time. So this is the same like CodeChef. As I explained, everywhere you have the same interface like problem statement over here, and input format and output format, and sample test cases. You will have explanation also here. For this problem, it's not there. Maybe we'll go with some other one. You'll have explanation over here for the sample test cases. And for submitting the code, in Codeforces by default, you don't have compiler like CodeChef. So you can go to submit code and select the problem of the contest. There will be generally 6 to 7 problems in a contest. So you can select the problem which you want to submit and the language over here, C++20. These are different versions. So you can just copy paste your code from the compiler you used. It may be a local one like VS Code, uh, code something, VS Code or something, or else you can have online compilers like USACO IDE. When you search USACO IDE, you will get this ide.usaco.guide, in which there are 3 options available: C++, Java, and Python. Let's say I've created a C++ file. You can write your code here, and let's say we are in the problem A. So we want to copy this input and test with our code. So you can write the code here and run it. So it will give the output over here. If you get any error, it's mentioned in stderr. So it's better to use online compilers like USAGO, or it's very much better if you use Visual Studio Code, VS Code. So if you use VS Code, you can just copy paste the same like this. Let's say I type something, I'll get an error. So this is a verdict over here. Your code is visible over here if you click that submission link. And if you get corrected, it gives accepted verdict, or else wrong answer, or else TLE, MLE, runtime, whichever is appropriate. Or else you can just select the file. If you use VS Code, you can select the CPP file. Something, let's say I selected some file, CPP file or Python file based on the language you select, and you can just submit over here. Yep, we got wrong answer verdict. So this is the contest page in Codeforces, and you have your submissions mentioned over here, standings mentioned over here. Standings in the sense the leaderboard. The
Guys, I guess there is a small issue from at his end. I guess, Naveen.
Yeah, yeah.
Yeah, can you take over and continue with code forces?
Just a second. Yeah, is my screen visible?
Yeah, yeah.
Okay. So, yeah, I think Silas explained majority of the part, but here if we see standings page, here you can see the standings of your friends and all. Like there is friend standings. Then you have rating changes, friend rating changes. There are a lot of extensions that you can put in Codeforces, which will allow you to see all these things. And also, the major difference between Codeforces and a platform like CodeChef is
There's a small power cut issue, guys. Have you been able to track everything that's been happening till now? Okay, nice, nice, nice. We're just going over all the platforms so that you guys you will find it easy to navigate through them.
yeah. Hello. So yeah, as I was explaining, you can see this rating changes, and the major difference between Codeforces and CodeChef is that CodeChef is more like math logic questions. Codeforces is purely proper competitive programming, so you get proper logic and algorithmic combination. So that combination is really good in Codeforces. And if we see, there are a lot of features in Codeforces. If I go to common standings, so I can see at exact which minute they solve. These all are fine, but after the contest, what happens is that you have an option to, if you see here, open hacking phase has ended. Means that after the contest is done, unlike in CodeChef where you can, where you if you make a submission that is final, mostly there won't be any change. But in Codeforces, it's not like that. Even after you made a submission, there is a option for people to hack your solution. Hacking a solution means that I can just see if it is during the hacking phase, it will show hack the solution. So in hacking phase, what happens is that people can find a test case which satisfies the conditions given in question. Like suppose if I say, if I go to the question of this contest, so here it has to satisfy these constraints, and satisfying this constraint, if your solution fails, given that, so basically in Codeforce, what happens is that in backend there is a master solution which is like the main solution. The answer that solution give that code gives you, that is the final answer. There's no argument on that. It's not like in Codeforces where it's more like hacker rank. I think many people did hacker rank, right? So it's like you have input and output. But in Codeforce, it's not like that. So whenever you submit a solution, the master solution generates the output. Based on that output and your output, it's evaluated. So due to the availability of master solution, you can write test cases which some problem setters might have missed. Like if I go here, so see, there are hacks. So here there are successful hacking attempts. If I open this, so someone has given this test case, which gave verdict time limit exceeded. So this test case was not covered in the test cases generated by the problem setters. So this test case was missed, and someone just generated this and gave this, and it was a successful hack, which means that the solution of that, sorry, in this exact case, it's time limit exceeded, which means that the code which was written by the participant exceeded the time limit in this particular case. But if you see some other cases, uh, okay, it's mostly TLE. Mostly you get TLE. This wrong answer case is very rare. But there are cases like that also, where you get the wrong answer, which means that the solution that was given by the judge and your solution is not matching. Even after contest is done, this can happen. So you have to be very careful in Codeforces. When you submit a solution, you have to be sure. So in many cases, what happens is that people just submit one solution, and if you feel like there is something wrong in that, please spend 1 or 2 minutes to think and submit another solution. Even though time might change, if this question is gone for you, you'll go somewhere down, like you'll fall down. So these are some important things in Codeforces. You have to be very careful when you submit a solution. You have to make sure that it is correct. Uh, so there have been many cases like seniors, and we also experienced this. Like we submit a solution, and if I submitted C, it is correct. So if you see this, friends, yeah, here C. Okay, I think. Okay, yeah, this is the wrong test case. But generally, what happens is that after this solution has been submitted, later it gets hacked. Then what will happen? Uh, from being this position, he'll fall down. Okay, his rank will change. So like that. So you have to be really careful. So that is also a major thing in Codeforce. This is actually interesting. You can try some hacking. This is a very interesting part of Codeforces, which is not there in any other coding platform. So that's the difference between Codeforce and CodeChef, and also this makes Codeforces a more proper CP platform, and also a very like it's more competitive, right? You don't only try to solve the question, you also try to hack other solutions, try to not get hacked. So it's very interesting. That's what makes Codeforces the most popular CP platform. So that is it, I think, for this Codeforces part. So here we have seen the standings, hacks, and problems, and all these were explained already, right? So this is like a standard thing. So that's what Codeforces UI might look a bit old. It is old compared to platforms like CodeChef, but the thing is that it has many features. So just don't try to.
Anna, someone has asked a doubt.
Yeah. Just a second. Oh, hacked in the sense, just a second, I'll explain. Uh, so as I was saying, getting hacked means it's like, see, you have submitted a solution. After submitting a solution, what will happen is that you missed some test case, which wasn't covered by the problem setter. Like if I go to this standings and I see this solution, and here there are some test cases, right? Like you have some 11 test cases. Now what will happen is that the problem setter missed one test case. Maybe there is some test case which they have missed, which someone gives you, and the solution, the actual answer and your answer doesn't match. So then it's like getting hacked. Hacked in the sense your solution is wrong.
Naveen, I'll show the demo.
Yeah, go ahead.
So let's say this is a contest 966 Div 3 which I participated. So in this contest, yep. For C question, I've submitted one code in the at the contest time. But what happened was, uh, I have made some silly mistake over here. Like it passed the main test. Like as I said, there were many hidden test cases already given. So my code passed all that. But later I realized that there was a test case which was not mentioned in the hidden test cases, but my code fails on that according to the problem statement. So someone can hack your solution, or you yourself can hack your solution. So the second happened with me. Uh, for hacking, it will be only for Div 3 and Div 4 rounds and educational rounds. So after the contest, there will be a 12 hours hacking phase in which you can hack other solutions or your solutions. The solutions in a sense only accepted ones. So if it's hacked, that means that there's a hidden test case which is not mentioned by the problem setter, but your code fails on that. Like you get a wrong output for that. So if it's hacked, it gets deduced from the standings, and you'll lose a point of that, and they'll get updated later in the system testing. System testing means whatever hacking phase, successful hacks out there, they will be added to the main test, and every problem which is accepted in the main contest gets again judged with the main test. So this is about hacking phase. And there are also other types of contests like educational rounds, which are generally after every 20 or 15 days. You can see over here educational round 179, educational and 180. So for this also the leaderboard is similar to ICPC style leaderboard, and you have Div 2 and Div 1s for which the leaderboards are different. So let's say I'll go with 1031 Div 2. So I'll open standings page. So unlike the past ones, you get only 1 point for every problem. So the problem with that is, if you solve first problem or last problem, you'll get the same point. There's no differentiation in the difficulty of these problems. So coming to Div 2 and Div 1s, for first question, the score you can obtain at the maximum is 500. For second one, it's 750. Third one, it's 1250. Fourth one, 1750. Like that, you will have different various scores over here. So when you submit the problem at 00, in the sense less than a minute, so you'll get 500 score. Let's check if someone submitted like that. No, we don't see any. We have 496 over here. So after 2 minutes, the user submitted that. So for 2 minutes, the score you can obtain gets reduced. It's depend on the problems. So for 750 rated one, no, score one, you got 18 points lesser. In the sense, for each minute, the score is reducing by 3 points. For this one, the score is reduced by 2 points for every minute. Okay. So you can see over here, after 3 minutes he submitted. So 3 3 is 9. 750 minus 9 is 741. Like that you will get. And also if you submit a wrong answer, which is wrong answer on test 2, test 3, like that. If you submit wrong answer on test 1, you don't get penalty. Okay. If you see here, for first one, I did nothing. I just, in the first submission itself, it got accepted. So it's just 500 minus 10 into 2. For each minute, it gets reduced by 2 for first one. For second one, it's 3. For third one, it's not like that. It's not fixed. It varies based on the scores. So for second one, I have made 2 wrong submissions. So for each wrong submission, your score gets reduced by 50. So I made 2 wrong submissions here and then got accepted. So my correct score should be actually 558. But as I did 2 wrong submissions, I got less, no, -100. And based on this score, you will be ranked. If that score is same, your rank will be same. So yep, this is about standings and Div 2, Div 1. Div 1 is also same, and Div 1 plus Div 2 global rounds. Everything will be this style leaderboard. But in ICPC, when you participate, you will get the Div 3, Div 4 type of leaderboard or edu rounds, like this, as already discussed. And also, there's hacking phase for only Div 3, Div 4, and educational rounds. There won't be any hacking phase for Div 2, Div 1s. This is ICPC style leaderboard. So we'll go with Edcoder now. Did you get about Codeforces? It is the main platform where we do CP. Thumbs up, hand raise. So Edcoder is a Japan-based competitive programming platform. So when you search for Edcoder, you'll get the first site itself, edcoder.jp. So if you don't have an account, do sign up. And if you have one, sign in. This is the interface of Edcoder. So these are all the contests which are upcoming. So in Edcoder, it will be similar to Codeforces, but most people do only Codeforces. Like hardcore CP competitive programmers do Edcoder also. And also for beginners, it is not the go-to platform. When you get to CodeChef, Codeforces, and when you're comfortable with that, start with Edcoder. So every Saturday, you will have a beginner contest, which is famously called Edcoder Beginner Contest, called as ABC. So there will be around 6 to 7 tasks with the different scores. So in Edcoder, the scores will be the same. Like if you submit it 1 hour, 30 minutes also, the score you'll get the same. Suppose I have submitted first question at 50th minute or something. I'll get the same score, but the tiebreaker here is time. So in Codeforces, the tiebreaker was score because time based on the time only the score is calculated for different problems. So here you'll get the same score, which is maximum, which is given 100, 200 something. I'll show you a past contest. So these are the tasks over here, the time limits mentioned and the memory limits. You can open a problem statement. So again, the similar interface with problem statement, constraints mentioned, the input format, the output format, sample input outputs. And here also you don't have any compiler provided by default. So you have to use local compilers like VS Code or else online compilers like Usaco ID. Or else you can select a file and submit. You can check your submissions over here in the my submissions or in the standings page. You'll have all the standings over here. You can filter over here. And you have editorial section here. So yep, this is the profile page. If you give Codeforces ID, it will be displayed over here. So every Saturday you will have Edcoder beginner contest at 5:30 in the evening. Every Saturday at 5:30 you'll have Edcoder beginner contest, which is similar to you can say Codeforces Div 3, Div 2 in the middle, Div 2.5 something. So this is about Edcoder, and I want to explain about some CPA reference websites like CP algorithms and USACO. So if you want to know about something, a CP concept more, and you want to learn from a reference book or something like a textbook, a resource, a proper resource, you can get from CP algorithms. So this is the interface of it. You can search for a topic over here. Let's say I want to learn segment trees. So you'll get all the details of the topic with a detailed explanation with images and demonstrations if needed, and various edge cases in it, and time complexities mentioned. And you'll also get problem links at the bottom regarding that topic. So this is one such platform which is CP algorithms. And also you can also refer to USACO, dot guide. You can search over here. Same, let's say segmentary. Segmentaries. So you'll have detailed description with the problem links, implementation, different problems with codes, time complexities, etc. So these are the go-to websites if you want to refer to different CP concepts. Apart from that, we also have CACS problem set. So when you start CP, you can parallelly go with CACS problem set. These are a fixed number of problems, which are about 300. Recently, they also added 100 problems, I guess. So the problems are topic wise. So these are standard problems, which are quality problems for competitive programming. If you want to excel in competitive programming, solve these problems, you can log in with your account and go with topic wise. So for every problem, there will be different concepts and different approaches for that. So you learn a new concept in every topic with CACS problem set. So try to solve CACS problem set when you get comfortable with CodeChef and Codeforces, and you want to improve your CP skills in different topics. So this is the one CACS problem set. Yep. I'll hand over it to Naveen. If you have
Yeah.
any doubts, you can ask about code, CP platforms.
Yeah, if there are no doubts, then I'll continue with the next topic. Uh,
Naveen, bro, can
yeah.
I have something to speak actually.
Hmm.
Yeah. Juniors, I'll give you an overview of what you're gonna learn. It's better you take down some notes, right? Right? Like Naveen, bro, is going to explain to you all some important topics. It will help you all to note down and revise them later so that you won't forget. Okay, the overview will be you learn about time complexity. I hope you already know about it, but we'll also go in a bit more deeper. And we'll have space analysis, and you know that we have sorting problems, we have greedy algorithm and bit manipulation. If you already know most of them, it's good. If not, this is what you can expect from today's class. And I'll hand over to Naveen Anna. And don't forget about taking notes. It will help. It will be very helpful to you all.
Yeah. So that, and even if you people already know these topics, I would recommend still listening because you might get to know something new. So with that, let's start with the first topic, which is the time complexity. So yeah, I hope my screen is visible. And so coming to the time complexity, first we have to know why do we need time complexity. So coming to the basics, a if it is the C++, then you can execute about 10 power 8 operations in a second. And if it is Python, then it will be about 10 power 7. Java also can take Java or C++, it's 10 power 8. But when it's Python, it's 10 power 7 only in 1 second. So if you see 10 power 8 operations, what do I mean by operations? It can be anything. 10 power 8 operations in the sense it can mean anything like a plus operation or a minus or a equality or even swapping can be an operation, depends. That depends, but swapping is actually 3 operations, right? So that actually depends on how you write and all. But in general, you can think like it is like a 10 power 8 operations, like the operations which are performed at the CPU level. So that will be done in 1 second. So seeing the 10 power 8, it might seem like a lot, but if you see, I think many have already solved some problems. Like even if it's in hackathon, that's fine. But if you have seen the constraints, it will be 10 power 5. So as I told, 10 power 8 operations in 1 second. So if the input is 10 power 5, so I'll get to how you calculate the time complexity and all, but I just want to give an insight why do we need time complexity. So if you see there is this 10 power 5. Now if you write an big of n solution, which means the linear time solution, that will be 10 power 5 operations, which will take a lot less than a second. So that will be a millisecond, I think. So that is very less. But if I write an n square solution, that will be 10 power 10, which will take about 100 seconds. May not seem a bad, but it's very, very bad in competitive programming. I mean, that can't even be executed. Like 1 minute, 40 seconds. In real life, it's not bad. 1 minute, 40 seconds is fine. But again, the difference, like from 1 minute to 1 millisecond, it's a lot of difference, right? This is like 1 ms. This is like 1 minute 40 seconds. If I go a bit further, let us say from n square to n cube solution maybe. So that will be 10 power 15. So now it's like almost not executable, I think. So that is like 10 power 7 seconds. That's a lot of time. So that's the reason why we need time complexity. So whenever we do competitive programming, the first thing that you have to definitely see is the constraints. So whenever you see constraints, so if you see it's 10 power 3, then you can think like n square will work because that will be 10 power 6, right? Uh, if you say 10 power 5, then n square will definitely not work because it's 10 power 10. So there have been many cases like where people, when you're a beginner, people might think like 10 power 5 is there. Let me try 10 n square. It might work and all. But in platforms like Codeforces and CodeChef, it will definitely not work. 100% you can take guarantee. Unless and until it's in some outside contest, there you might think of trying if the test case are weak. But if it is Codeforces, then definitely n square will not work. Even if it works, I mean it will not work. Even if it works, then test case are weak, and anyways your solution will get hacked, right? So that's the point. So once you are at a intermediate level in CP, then people what they do is that they just check the constraints and they'll see 10 power 5 is there, n square will not work. I'll not even try that. So you shouldn't waste time in competitive programming, as we have seen. Based on the time your rating gets decided. So you should always see the constraints and see if your solution will work or not beforehand. So it's important to know how you can calculate the time complexity. So this is just a brief. Now let us get into some formal definitions so that we can understand how we can calculate the time complexities. So one major thing that you have to know whenever you talk about time complexity is the big O notation. So big O notation, which is like an upper bound. So this is the upper bound. I'll get to that, what is an upper bound, what and all. But we first need to know some formal definitions so that we can understand how we can calculate the time complexity, what is time complexity, and all. So as I've shown in the previous case, here operations are there. This is more like calculation of seconds if you do in code. That is more like practical analysis, which is not really used much. This is more like a theory analysis. So we analyze the algorithm in theoretical way. Like when we write algorithm only, we'll try to use some notations and try to calculate the time complexity. Here I was saying n square, right? That is theoretical. But when you go to operations and try to calculate that and write in code, then that is practical. So whenever you before writing solution, you have to have that theoretical estimate, right? How much my solution is, like what is my solution? Will it be executed or not? So that should be there. So that's why we need some formal definitions. So this is the one of the major one, big O notation. So if I see here, the big O notation has a definition, which is this. I'm not writing the whole definition. I'm just writing the thing which we need. So for all, so this is like a proper mathematical equation, right? So then you can say f of x is. So here, what does this definition say? This definition says that if I have a f of x, I can say that it has time complexity big O of g of x, given that this condition is satisfied. Okay, for any x naught and c. So for any x naught comma c, this condition should be satisfied. What does this mean? So let us take an example for this. I'll take this function, a very simple thing. So okay, this might seem more theoretical, but if I show it in a loop, maybe you'll understand better. So this will be like so okay, let me write loop. So I equal to 0, I less than 100, I plus plus. And inside what will happen? J equal to 0, J less than and J plus plus. Okay, so this if you have some statements here, then again there is another loop. I equal to 0, I less than 5, I plus plus. Then this entire thing will give you this equation, right? Like I have outside loop 100. We'll get to know how we count the time complexity for this loop, but I'm just I'm giving an example so that you understand that this function is not some random mathematical function. It's actually taken from a code. So this is the code of it. So if I take this function, now I want to know what is its time complexity. So if I want to know its time complexity, I have to, so this is like f of x, right? Now I have to know g of x. So what is my condition? My condition says that for any c into g of x, this should be greater than, which means that I have to find out c, and also there is this condition, right? So now what I'll do is that let me start with n square. That is a bit easier to explain. So what I'll do is that I'll take g of x equal to n square. So 100n, so 100n plus 5 is less than or equal to c into n square. So now I have to find the value of c and x naught. C I can take anything. Let us take c as 1. Not 1, maybe we can take 100, 101. Anything is fine. You can also take, I'll actually take 1 only. C equal to 1. So that will become this equation. So now x is greater than or equal to x naught. We have to find the value of x naught. Okay, maybe I should have written this, n greater than n naught. Okay, so this is like a proper quadratic equation. So I can solve this. So this is the equation. You can solve this quadratic equation, or else what we can do, we can take this equation and do hit and trial. So I'll just do hit and trial. Like let me take 100, n equal to 100. So that will become this. It's not true, right? So it's not true. Let me take 101 now. So that will become 100 into 101 plus 5 greater than equal to 101 into 101. So that will be what? 100 into 101 plus 101. So it is greater. So n naught is equal to 101. So here I can say that the time complexity is big of n square for this function for c equal to uh, for c equal to 1 comma n not equal to 101. So now if you see, the loop was more looking like linear because you just had 100. This is like constant, and outside it is n. But why did I say it's n square? That is because it's the big O, worst case. So it is the worst case. So here we can write n square. And if it is n square, then obviously it will be n cube also. Why? Because it's the worst case. Now let us do one thing. We'll take big O n now. So g of x is equal to n. Now if I write the equation again, n not greater than n greater than n naught. So now in this case, what will happen? Uh, if you see one thing, you can't take c equal to 1. Why? Because if I take c equal to 1, so that will become this. That will become 99n plus 5 less than or equal to 0. One thing you have to note here, n naught can never be negative. I mean, not n naught, n can never be negative because n denotes the input size, which can never be negative, right? So this equation can never be true. Similarly, if we see, c cannot be less than, less than or equal to 100. This is not possible. Why? If you do that, then it will get cancelled always. So c should be 101. By hit and trial, I understood that c should be 101. Now, now I want to know the n naught value. So here, what will happen? If I take 1, it will obviously not satisfy because 105 this. So if I take 2, 205, 202 again not satisfying. It will not satisfy until you take 6, right? So 605 greater than or equal to 606. So n not equal to 6. So you can say big O of n. So this is true. If I want to show this in graph, what is happening here? So let us assume that this is our function. This is our f of x. G of x is a function which goes like this. This is the x naught. So here what is happening? G of x is surpassing the f of x after a point. But once it surpasses, it is never going below f of x again. So that is what the upper bound denotes. Once the g of x is over f of x, it will never be less than f of x. So we have to know that point. That point is x naught. So that's why we are doing these calculations. So that is one thing. And if you see, if I show you this equation, instead of taking 100n plus 5, I'll take this 100n square plus 5. In this case, what will happen? Can I say that it is big of n? Let us check. Let us check if I can say. So what can be the value of c? Let us take 101 again. So now I took 101. So when I put value, no matter what n value I put, okay, this will never be satisfied. I think you can try with 2 also, it won't satisfy. 3, no. So like that, no matter what n value you put, it won't be satisfied. So here you can't say that it is big O of n. As I told, big O means worst case. So obviously you have to take n square now. If you take n square, you'll get proper c and n naught values which will satisfy. That is correct. So one thing that you can notice here is that if you take a function which is like this, you have to consider the highest term in that function. That term will become, so in simple terms, this is all mathematical definition. You definitely won't need it in your CP journey, but it is important to know what is time complexity. Theoretical things are also important. So, but the bottom line is you just need to see the highest term. So even if you write in your code, you have to see the part which will take the highest amount of time. So here, if I see, if I have written this function, only n cube matters for me. So it will become big of n cube. So you can ignore the constants, you can ignore the small lesser terms than this. Why? Because we are only considering the worst case. So that will be the highest term in that. So if I take this number line, I mean the order, so that will be n power n is greater than n factorial greater than 2 power n greater than, then you can take your polynomial times n power 4 n cube, then you'll get your n square, then n log n will come. We'll discuss about log n. Then n will come, then log n, then you'll finally get 1. Okay, so this is the order in which it is, decreasing order basically. So in this order, so basically if I have a function with one n log n and one n square, then n square only matters to me. N log n doesn't matter. Sorry, log n doesn't matter to me. So that's how it works. So as I am telling here, basically this is like a property. So if I write this function, so only the maximum term function matters to me. If this has a time complexity of g1 of n, this has time complexity of g2 of n, then max of this will become my big O. Okay, so max of that will become my big O. So that's my time complexity. So that's what, whenever you have a function, only the max term will matter to you. Other terms won't matter much. So this is the big O. We mostly use big O only, but it is also important to know what are the other notations. So there is another notation, which is the omega notation. So this is the omega notation, which is lower bound. So here what will happen is that f of x is greater than or equal to c g of x for every this. And also then it will become f of x time complexity will be omega g of x. Okay, this is your time complexity in omega notation. This is not really important. That's why I'm telling bit fast. Only we'll use big O only, which is the worst case time complexity. So here what is happening? So if I have a function like this, so this is the best case. So if even if I have a function which takes n square time, I can still say that it has a time complexity of omega of n. Why? This is the best case. It's not like the worst case. We are, so basically in simple terms, worst case means greater than or equal to. This means less than or equal to. So if I have n square, I can definitely say it's n log n 1. But if when I have n square here, I can only say it's n square, n cube, and n power 4. So like that. So this is the lower bound. We won't use it much. I'm just telling so that you get to know. And there is another thing which is tight bound. So this is the theta notation. Which is a tight bound. Here the definition is like C1 g of x less than or equal to f of x C2 g greater than or equal to, sorry, less than or equal to C2 into g of x. Again, for every x greater than or equal to x naught. So here you have three constants, x naught. So then you can say f of x is theta of g of x. So this is like the average case, okay? This is like the average case. It gives you the approximate, not approximate, close to estimation. So this, then it is called theta notation. This is the average case. So if I draw the diagram here, if this is your f of x, then this will be your g of x. Here, if I draw, this is your f of x. This maybe not like this. Maybe you can say it is going closely. Like it could pass like this or pass like this, depending on this constant. So that is close. So in this theta notation, whenever you have a function like this, you can only say it is theta of n square. You can't say it is theta of n cube or theta of n. Why? Because either of the condition won't satisfy. If you say n cube, this condition won't satisfy. If you say n, this condition won't satisfy. So that is the theta notation. Anyways, the final thing is that you only use big O. So whenever you have a solution like this, you'll say big O of n square. Whenever you have a solution like this, you'll say big O of n. So that's the point. And if we see, so whenever you are about to write a solution, what we try to do is that we try to know its time complexity first. So that is the most important step, so that you could understand if your solution works or not before itself, without writing it, submitting, getting it yearly. So that's a lot of time waste. So whenever you write a code, okay, if as you're just starting your CP, you can write a pseudocode and then check what is the time complexity. But once you get to kind of intermediate level, then you can think in your brain only, like, this is the solution, what is its time complexity, will it work or not? So end it there. So there have been cases where in Codeforces, what you could do is that, there have been cases what I used to do is that I didn't check the constraints when it's a easy problem. So in that, what used to happen is that n used to be like 100 or 1000. So n square would have worked, but I used to overthink and write an n log n solution. So due to which it's time waste, right? So there have been cases. So these are the smart things that you need to do. Just check the constraints. This is generally like A or B. So it's like a in div 2, not a in div 2 also, I think. It's more like a in div 3 or div 4. There what will happen is the constraints are very small. Your brute force solution will work. So yeah, these terms are also there. What is a brute force solution? A brute force solution is like, say what they told you to. I mean, do what they say. So if they have said like do that, this, like, you exactly implement what they said. You don't apply any logic, or you don't try to simplify it or make it better or faster. That is a brute force solution. So this generally has a higher time complexity, more like a n square. Sometimes it might even go to 2 power n, like that. It has very bad time complexity. That's why brute force solutions are generally not. I mean, problem setters generally ensure that brute force solutions fail. So, but if it is a or B in div 3 or div 4, brute force might work. So you have to be careful. Not careful. It's just to save your time. Just see the constraints. You see n is equal to 100. Okay, I'll try. I can even write an n cube solution. Doesn't matter. So like that, you have to be a bit smart sometimes. So this is the time complexity part. So to know the difference, why we need this time complexity, I'll take an example. So previously I was showing you, right, how many operations and all. So these are just to show you what is this and how to calculate the time complexity. But let me take a proper example and tell you what will happen in general real life. So the example that I'll be taking is a linear search and binary search. So in a linear search, what will happen whenever you have an array of elements, let us say like this, you just check each element one after other, one after other. It's now you have to think in way of time complexity. What is its best case time complexity? I'm not talking about these notations, okay? there is a difference between when I say best case time complexity, worst case time complexity, and saying what is its theta notation. Okay, that's a difference. Best case time complexity means that in the best case, what could happen? Your element could be in the first position only. Then the best case becomes big O of 1. That is the best case time complexity. Then you have average and worst. Average doesn't matter actually. It does maybe. So let's write. So average case. In average case, it will be linear, which is big of n. And in worst case, what will happen? Worst case is like the last element, or actually worst case is not the element not existing in the array. Then you have to scan the entire array, right? So that will be again big of n. Similarly, binary search. I think everyone learned binary search, right? In this your DSA course. So in that, okay, I'll simply brief what is binary search. Binary search is like you'll search the mid element because the array is already sorted. You'll search the mid element. Then, if the mid is equal, then it's done. Your search is done. If it is not, then as the array is sorted. So if I have 7 that I want to search, this is like 6. If the array is already sorted, then is there any point to search in this place? Because this is 6. Then obviously the elements less than 6 only will be there here, right? In this left part. So there is no point in searching here, right? So that's why we'll abandon this entire part and only search here. So that's like you compare with this. If it is less than this, you move to this place or you move to this place. So it will go like that. So that is the binary search. Each time we are skipping the half. So if I write it, best case could be the middle element itself is your the element that you are searching. So that will be best case 1. Average and worst case is log n. So I'll explain how we got log n, but I'm just writing it down. So how did we get log n? We are getting log n because each the number of operations that we are doing is getting reduced by like the array size is initially n, then it got reduced to n by 2, then it got reduced to n by 4. So finally, it will reduce to 1, right? It will go to 1. When will it go to 1? When n by 2 power k, okay, let us take when it will go. N by 2 power k equal to 1. This makes it 2 power k equal to n. This is equivalent to saying n equal to log n base 2. So these are the number of steps. K is the number of steps, which is log n base 2. So how good is log n? It is really good, like very, very good, because if I take n equal to 10 power 5, so linear search would take 10 power 5 operations, which is not much because you could always execute this 10 power 8 operations in 1 second. That is 1 millisecond. So 10 power 5 operations is very good, not bad. But let me do one thing. I will take 10 power 8. Just for reference, 10 power 8. So that took 1 second. Good. But if I take log, how much is this? That is like 8 into 3.3, which is like, you can say, 8 into 3.33, that is like 26. So can you see the difference from 10 power 8 operations to 26 operations? That's like a huge difference. So basically, generally what happens is that whenever you write n log n, it's more like log n can be considered as constant, because even if you take 10 power 8, it's only giving you 26. So that's very less, right? So log n will always almost become a constant. So that's how good is log n. So n square and log n, there's a huge difference. Okay, it's not very small difference, it's a huge difference. So that's the difference. Now we'll try to understand how can we calculate the time complexities. So I was previously explaining this, right? How we denote time complexity, how is it, and all that. Now our aim is to calculate the time complexities. So we'll try to understand how we calculate the time complexity. For that, there are two methods, which is the count method. Count method. So, okay, well, let me first talk about count method only. So this is the iterative. So what is a iterative algorithm and recursive algorithm? Iterative algorithm means generally you write it using loops. Recursive algorithm means calling a function inside a function, right? So then time complexity analysis becomes a bit different because it is a recursive solution. But if it's an iterative solution, you can use a simple count method. So let me take an example and say what is a count method. So let me take a very simple code, which is the finding the max element. So if I write that, and okay, I'm considering the array is only positive elements. That's why I took it as 0. Otherwise, you have to take it a very small value, right? Maybe you can write that only. That is better. So int yeah. So if let us say it is array of I greater than maxi, then max equal to array of I, right? This is a very simple code which finds the maximum of an array. So if I want to calculate the time complexity of this, then I have to know how many times this loop will run. How many times does it loop run? N times, right? So this is the count method, which tries to calculate how many times it's running, and based on that you get the time complexity, which is big of n. Let us take a bit tougher code, which is this. So how many times does this execute? For this, we need to know, we have to calculate it. So let us take one I value, well, let us fix the I value, then find out how many times this runs. That will be easier, right? So when I equal to 0, this will actually run for n minus 1 times. Okay, because j equal to 1, j less than n. So it will run for n minus 1 times. I equal to 1, n minus 2 times. Like that, if we go till I equal to n minus 1, it will become 1, right? Sorry, 1 not 1, it will become 0 actually. So that is the thing. So it is going from n minus 1 plus n minus 2. It will go on till 1. So that is n into n minus 1 by 2. Okay. So this is the number of times that loop ran. This statements inside it will run. So that gives you the time complexity of n square, right? Because if I expand this, that will become this. So the highest term is n square. So that will become n square. Okay. So this is the time complexity of this loop. If I take a last example for iterative approach, so I think everyone must have understood what is an iterative approach, how it is working. Last final example, let us take this code. So I'm taking this code, which is, what is it doing? For I, for a given j, it is executing this. So here, what is the time complexity? For this, I have to calculate. Let me take I equal to 0 again. I'm fixing the I again. I'll again fix j. Let me again fix the j. So j equal to 1. How many times will this run? That will run for log n times. Why? Because each time it is growing by 2. So when k equal to 1, then k will become 2. Then it will become 4. Then it will become so on till 2 power k, while 2 power k is less than n. So this is log n, right? It will run for log n times. log n base 2 times. So now that will become log n. Similarly, this j will go till how many times? It will run for n minus 1 times. For n minus 1 times, it is log n. That is for I equal to 0. Similarly, for I equal to 1, that will be n minus 2 into log n into. So we can write this actually n minus 1. We can take log n base 2 outside. That will give me till this 1. So that will become n into n minus 1 by 2 into log n. So that is big of n square log n. Okay. So this is how you calculate for iterative approach. Now if I take, so that is the iterative approach, that is the count method. Now what I'll do, I will write a recursive algorithm. Let me write first let me say that for this you use recurrence relations. So you'll learn this actually. I think you will have this course. I think it will be there in second year, right? So in that you will learn what are recurrence relations, how to solve them. But I'll just tell briefly how you can calculate the time complexity of a recursive algorithm. So this is the recurrence relations. This is for recursive algorithms. For this, you can calculate the time complexity using this. So let us take a very classic example. So here, what I'll do is that I will take a very classic kind of example when a recursive code. So factorial. If n equal to 0, then I'll return 1. Else I'll return n into fact of n minus 1. So this, if you can see, this is a recursive code. So to know the time complexity of a recursive algorithm, you have to write something called as a recurrence relation. So in recurrence relation, what you do is that you represent the function as t, this as t, and you try to know what is the next step. So that is t of n minus 1 plus this is the time complexity required for this operation. So this multiplication operation requires big of 1 time, and it is again getting expanded to this. So this is how you write a recurrence relation. T of n equal to T of n minus 1 plus big of 1. So to solve this, there are many methods. With one of the most easiest and common is substitution method. So it is like repeated substitution. So what I do, I just write like this. So that will give me this. So here, if I assume that is k, now what will happen here? T of 0 is equal to 1. So in this case, what will happen? So n minus k equal to 0, which will give me this. And so that will become T of 0 plus n. So that is n plus 1. The time complexity is big of n. So I just actually what I did, I just calculated how many times this is running, how many operations it's requiring. So that gave me the time complexity of this thing. So this is how you can calculate for recursive solutions. It is not very simple, but with some practice, you can understand. Like if I write this, another classic example, Fibonacci number. Let us say if it is n equal to 1 or n equal to 2, we'll return 1. Else return Fibonacci of n minus 1 plus fib of n minus 2. Okay, so this is the Fibonacci code. If I write the recurrence relation for this, that will become T of n minus 1 plus T of n minus 2 plus big of 1. Now this is very difficult to solve. So we can do a small approximation here, which will make things a bit easier and also won't change the time complexity much. So this is the small manipulation that I did. I took this as approximately this term. So now if I solve this by repeated substitution, you can try that. You'll get this. big of 2 power n. Sorry, just a second. Yeah, it is big of 2 power n. So this is the thing. For recurrence relation, you have to write like this and solve it. Then you'll get the time complexity. Or else you can, yeah, this is how you get it formally. So for recursive solutions, it's a bit tough. But iterative, I think it should be easy, right? I'm just counting loop and I have to just multiply and add normal basic things. So this is for recurrence relations. So is it clear, everyone, till here? Or do you have any doubts in time complexity or how do we calculate and all? Yeah, just give a reaction if it's clear. Yeah, so that is more theoretical part. But as I told, I was giving some examples, right? Why you would need it in CP, because constraints are very important in competitive programming. You have to understand why do we need that. And final thing, I was just talking about time, right? But there is also this space. So you have to generally space doesn't matter. You are always given like 256 MB. I think everyone must know how big this is. That much memory you are given, or you are giving this much, or almost a GB. So memory doesn't matter generally to us. But so that's why we don't do a space analysis, space complexity analysis before writing a solution. But if you go to advanced level of CP where you might write some like segment trees or some other things, then you might need it. But for now, for a start point, it's not required. So, but there are some important considerations that are required, which is that you need to know the range of int and long long. So this will be further discussed again in bit manipulation, which is there for today. But what is int and long long? So I'm considering signed. Okay, here. What is the difference between signed and unsigned? I'll tell that also. So signed int and signed long long. So the range of signed this is minus 2 power 31 to 2 power 31 minus 1. So total you have 2 power 32 places. Sorry, I mean you have this. It's generally stored in bits, right? We'll go to that again in bit manipulation, but it's more like you have 32 places. So in that you can either put 0 or 1. So that will give you 2 power 32. And for sign long long, it is minus 2 power 63 to 2 power 63 minus 1. What is unsigned? Unsigned int means it is 0 to 2 power 32 minus 1. Okay, this is unsigned. Unsigned long long is 0 to 2 power 64 minus 1. So these are the ranges. So one thing you have to be careful whenever you write, like whenever you take int long long, you have to be really careful because in some things like they might have given 10 power 5 array elements. Each element is like 10 power 9. So then if you do sum, will it fit in an integer? Okay, by the way, this I have written in 2 powers, but if you write it in like 10 power, that will be like 10 power minus 10 power 9 to 10 power 9. Approximately, I'm telling. We'll take approximations here. So actually it is 2 into 2 into. So this is like 4 into. So this is like 0 to 9 into 10 power 18. And this is like 0 to 4 into 10 power 9. Okay, that's the difference. So if you do this addition, that will become 10 power 14, which will not fit in an integer. Then you have to declare a long long. So in that case, what will happen? If I write that code, Here, what I'll do this. Okay, I will not like do it like this. Yeah. So here, if I do this for the above given constraints, that sum won't fit in this. So that's a problem. So that's why you have to declare long here. So then it will fit. Then you're fine. So what I'll do, I'll declare it as long. Then it will fit. You're good. And another thing that you have to consider in this scenario is that uh, whenever you have, whenever you're declaring it first time, let us say you're doing it like this, long a value. So basically what I have is that I have a value and I have a b value, which are both integers and which are both like 2 power 31 minus 1, 2 power 31 minus 1. Okay. Now you'll think like I added a plus b and here I have declared long, so it should fit in long. This should be fine. But it's wrong. Why? Because when you add an int plus int, it will give an integer, not a long. Just because you declared that it's a long here value doesn't make this a long. You have to explicitly cast it. You have to explicitly say that this is long. Then compiler will first change this to long. Then it will do an addition. So long plus int will give you long only. So then it won't be a problem. So just be careful with these things. Okay, whenever you're writing like this or like this. Generally in competitive programming, what we do, if you're using C++, we just use long. We won't use int at all, just to be sure. Okay, there have been many cases where the range wasn't fitting in integer, or there were things like this which would give you a wrong answer. So whenever that's what, be careful whenever you're submitting solution to CF. The wrong answer should be because you have a logical error and not because of these errors. Okay, just do one thing, just use long. If it is C++, then you won't get any errors. So that's it for this time complexity. How do we calculate the time complexity, and some what about space and some important considerations. Now Vishwa will take up the next topic, which will be sorting. Yeah, I think Vishwa is having some problem, so I'll just start with it. Like, just give a brief first.
Hello.
Yeah.
Yeah. So am I audible?
Yes, you're audible. Continue.
Okay. Done then. So I guess Naveen has covered most of the topics. How many of you are still with us? Just raise your hands. Oh, yes. There are so many with us. Okay, that's good. I didn't expect this. That's very good. Good. Okay, done then. So
I'm gonna cover sorting and greedy for now. Okay, let's just start with a question. So you know what is sorting, right? The word says it. Just spam the sorting methods which you know. Just message in the chat. What all sorting techniques or sorting methods you know? Like, are you familiar with this topic? What is sorting? Are you done with this? Okay, we got one. Ritika merge sort. Okay, quick sort. Sahiti. Linear. Linear sort. Okay. Merge radix. Radix is a good word. Quick heap, bubble, radix, sleep, selection, insertion. That's great. Okay, good, good. So you know few sorting techniques. Counting sort. Okay, great, Vivek. Any other buzzwords you want to hit here? Any other new sorting you have invented? That's it? Okay, great. That's good. We'll start with the topic then. I'll share my screen. So this is visible, right? Okay, done. So we'll start with the question right now. I'll present this. Okay, just go through this question once. You are given an array of integers. Find the pair of elements with minimum absolute difference. So you are given some array like this. The input is 3, 8, 15, and 1. Your output should be 2. You need to find the minimum absolute difference. So give it a try for 20 seconds and answer me in the chat. I'll be looking into the chat. How are you gonna find this? Let it be right or wrong, just answer it. We'll discuss it there. Okay, bucket sort, that's good. You got the question right? Sort and sliding window. Okay, that's a good answer. And can you show the question? Okay, this is the question. You are given an array. Imagine you are given a list array vector something. You need to find the minimum difference pair. You know what's the minimum difference pair, right? Just the difference between any of the two numbers in that particular array. So the absolute word means that you are applying mod on it. So is the question clear, Ritika? Sort and 15 plus 2. Yeah. Okay. We'll discuss about it. Who said this? Saba. For suppose. This is your question. What will be the answer, Saba? Saba only, I guess. Yeah. What's the answer for this, anyone? 1. That's right. So what are we doing? Yeah, clear. So we'll go through the solution. We are just sorting it. We are just finding the difference. Like 1 and 3 ka difference is 2. 3 and 8 is 5. 8 and 15 is 7. We are getting the minimum of the answer. So what will be the brute force for this? The general brute force application before you don't know what sorting is, you will do an n square loop. You'll find each differences and you'll give the answer, right? So sorting helps you to reduce the complexity from O of n square to O of n. I guess you are familiar with all of this since Naveen has explained you what all time complexities mean. We'll jump into the topic now. So what is sorting? Why is it important? Sorting is nothing but you're arranging them. You're just a second. You're arranging the given array so that they are in a particular order. Let it be decreasing or increasing or so. Okay. So that's what sorting means. Now we are going to cover different problems involved in sorting and time and space complexities overview. So these are the examples of sorting algorithms which you have just said in chat. We'll go through, we'll just, this I have pasted it to just see the overview of best, average and worst case complexities. So while observing, for suppose let's see this selection sort. What's the best case? O of n square, average n square, worst case n square. Okay, what about quick sort? N log n, and O of n square. So what is a major observation in this? While considering any of this algorithm, which do you think is most important to worry about? The best case, worst case, or the average case? What do you say? Average case, worst case, average case. Okay. Any more answers? Anyone? Come on, there are 92 people, excluding 20 of us. There are something around 70 people, I guess. So these are different time complexities. What do you think we need to worry about? The best case, the average case, or the worst case? Worst, worst, worst. Yeah, that's great. Imagine you are planning for a trip, you are going somewhere out. You will be prepared for your worst case scenario, right? So that's the case here. Always you worry about worst case scenario, and this is auxiliary space. I guess Naveen has explained you about time complexity and space complexity. This would be a good example to compare different scenarios of that. Okay, done. So what is your language, core language which you guys are using? C, Python, Java, CPP. Just text me your language. C, 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 C. Okay. So you guys use only C, Python. Okay, one Python, CPP. Okay, those all who are using C, how do you implement a sort function? For suppose we have seen this question, right? You need to sort it and you need to find the difference of this. As one of you said, you need to sort it and you need to find the difference of each of the pairs. So how do you implement it in C? Yeah, Q sort. Good. That's great. Now, if we jump into CPP, we have something called as library sort. Okay. So we'll import it from the algorithm, and the syntax is like you will have a start and end. Okay, this is the basic. There is a third argument. We'll discuss about it next. So this is a library sort, which is a hybrid sort function. That is a combination of, you can say, quick sort, keep sort, and insertion sort. So internally, all that stuff goes on. So that worst case time complexity of this would be n log n. That's what's the main thing you need to remember. Okay. So this is a basic example how you need to implement a library sort. So this is a vector you are declaring here. This is the function sort v begin and v end, means you are going to sort from the beginning till the end. And this is a for loop to print the output. So this is the output 13479 done. Now, so as I said, there is a third operator parameter which you can say as custom parameter. This custom parameter helps you to sort with your own logic. If you are familiar with lambda functions, that would be easy to understand. So just imagine you want to return there is an array, you want all the even numbers to be present at the beginning and odd numbers to be followed by that. So what you do is you declare a custom function like this, where if there are two integers a and b, if a is even and b is odd, so what do you say? A should come first, right? So you'll return true. If the reverse happens, the vice versa, you return false. So what happens is you get the output according to your own intuition. So that's where the custom function is useful. You might not use it right now, but in future cases you will use it. Okay. So that's the basic of library sort. Now, these are few classic problems where you need to sort and you need to implement two pointers. So how many of you know what is two pointers here? Just give me a thumbs up or tell me yes, no, I don't know, maybe. You guys know what's two pointers? Don't know. Okay. Bhavana knows. Others? You didn't hear about it? Okay, you guys don't know about it. We'll try to cover it later then. We'll try to take class on that. So sorting, it would be a very basic, the first step of the whole problem implementation. So you use it generally while doing two-pointer problems, greedy problems, or binary search problems. So that's I guess binary search, you guys know what's binary search. So you know the implementation of sorting and binary search. Okay. Now we'll go towards another problem here. Yeah. Read this problem now. Given an array, the task is to find the most frequent element in it. If there are multiple elements that appear a maximum number of times, return the minimum element. Okay. So basically, you need to find the frequencies of the element. So the question is clear, I guess. You are given an array 10, 20, 10, 20, etc. You need to find occurrences that repeats maximum number of times. So what would be your solution? You can unmute, you can text. So is the question clear? This is very basic question. Yeah, hashing. That's a good way of solving it. And any other solution? Counter. Okay, we'll talk about it. And by storing the value and representing as keys and store them in a hash map. Okay, great. That's hashing. And Okay, can someone explain me the brute force of this? The brute force solution. What can you do? If you don't know any of this hashing, what will you do? You can unmute if you are lazy to type. Loops, that's great. Okay, yeah, that's the answer. The loops is the answer. Okay. I didn't get you, Likith. What do you mean by counter? You mean hashing, or you have any other idea on that? You can explain if you have any new solution. Okay. You want to increment and decrement if dissimilar element occurs. Then how would you return the element? You need to return the element which appears maximum number of times. Can you unmute and answer, Jatin? You want to increment and you want to decrement if dissimilar element occurs. But I need the element which occurs maximum number of times. Uh, you want to answer or shall I move on? Okay, I'll come back to you later. So this is a problem. So the brute force, you all know that you need two nested loops. Someone have already answered it. Loops, Saba, I guess. You need two loops. The complexity will be n square, and the space complexity will be 1 because you don't need any array or vector to store any of the values. And the second solution proposed was a hash map solution. So some of you, like most of you, said that is a hash map solution. So what happens here? You need to iterate it. You need to store it in a hash map. I guess most of you are familiar with hash map or dictionaries. That's basically key value pair. And the space complexity will be O of n because you need a hash map. That's obvious. Done. And the third solution would be a sorting based approach. What can you do on it? You can sort the given array like 10, 20, 10, 20, 30, 20, 20, right? If you sort it, you will get 10, 10, 20, 20, 20, 30. So for sorting, you'll take n log n solution for using some sort function. And then in a single pass, you can say that you can say what's the maximum frequency by comparing the adjacent elements. So if you encounter similar element, you set a counter. If you encounter dissimilar element, you set the counter to 0 again. And the space would be O of 1. So this is a sorting based approach. Okay. So did you guys understood these three methods? Just give me a thumbs up or else yes in the chat. Okay. Nice. Good. Great. Done. So you guys got this. So these are three methods. So just try to explore all the different methods you can solve a question and what would be the optimal solution. Okay. So if you are required to minimize the space, then you can go with the sorting based approach, or else if you don't worry about space, you can go with hash map or sorting based approach because n or n log n, it's almost the same. Now let's dive into greedy. Okay. Greedy. So what is greedy? In real life, what do you mean by the word greedy? Just tell me, what do you mean by some person is greedy or someone is greedy? Yeah, you can answer. I'm watching. Please be interactive. What do you mean by greedy? The word greedy. Wants money. Yeah, okay, that's good. And who is never satisfied? Yeah, human beings are like that. And that's it. Any more answers? What do you mean by greedy? More desire of something. Yes. Yes, you are coming towards the solution. So basically, who never worries about the effect of their work. Oh my God. Okay. Yeah, that's good. So, what does greedy mean? It's basically you want something more and more. You want to you want to make yourself something maximum. You want to increase something. That's what greedy means. So, greedy algorithm picks the best current option of the given steps. So, what does it mean? For suppose you have some chocolates in a row, you want to always choose the best chocolate with for yourself, leaving all others for others. So that's what greedy means. So what you will do is you want to choose the best option out of the given options, right? So greedy is basically an intuition based approach. Now coming towards the context of CP, we are done with the real life. We'll talk about CP now. Greedy is something which is an intuition. So what happens is when you are watching, uh, let us imagine that you want to solve a problem. Greedy is one of the technique where you want to minimize or maximize the local minimas or maximums rather than worrying about the global thing. Okay, so what you do is, so greedy in a greedy solution, you first try to define understand the problem and define the choices. After that, you want to maximize or minimize something. Okay, for that, what you will think is, acha, we'll suppose think of something like, if we maximize this problem, we may go through the solution. So that's an intuition of yours. So you will basically purely go on the intuition, or you can say your gut feeling, such that you will reach a solution. That's a greedy problem. So what you'll do is you always try to maximize the local steps, hoping for the best solution. But what happens is, if you know about local minima and global minima, the main drawback of greedy would be you might reach to the local minima rather than the global one. So there you might fall into a smaller pit than the bigger one. That would be a drawback of greedy one. So uh, if you are not much familiar about greedy, we'll go through one solution and we'll try to understand what does that mean. Okay, we'll go through this question once. Okay, now I guess this question is visible for everyone. Just read this question and think about it for a minute or so, then you give me your solutions. You can go through this example also. Okay, I'll paste this question in the chat if any of you wants to refer the question. So, did you all understand the question, or you want me to explain it? Did you get the question, everyone? So, should I explain? I'll explain the question once. So, first, suppose leave about the story. So, basically, you are going somewhere. You need m number of meatballs. You need at least m number of meatballs, and there are these are the packet of meatballs. You want to minimize the number of boxes you want to carry. Imagine. So this is a box of 4. This is a box of 3 meatballs. This is a box of 2 meatballs and 1 meatball. You want to minimize the number of meatballs, number of boxes you want to carry, while you need at least m meatballs for the trip. So what would you do so that you will minimize the number of boxes and you'll get at least m meatballs? So any solution? Okay. For each case, output the minimum number of plates to get at least m meatballs. If not possible, then output -1. You want to output minimum number of plates to get at least m meatballs. I didn't get you. Can you just unmute so that we can discuss about this, your solution? Karthik? So these are the plates. This is a plate 1, this is plate 2, this is plate 3, and this is plate 4. P1, P2 till Pn. All these are plates. You have 4 plates and you need 7 meatballs. So their explanation is, if he takes third and fourth plate, you will get a sum of 7, which satisfies your constraint of 7 meatballs. So you'll return 2, which means that 2 plates would be enough, which is 3 and 4. First, it's not changing. Yes, that's what the solution is. Correct, Varun. Anyone, any more ideas? Okay, I guess we are running out of time. I'll explain the solution for those who didn't understand. Yeah. So what we'll do is, as Varun said, we'll sort them, and removing the complexity, we'll reverse the list, because I don't want to iterate from the end. I'll iterate from the beginning itself. I have sorted, I have reversed. Now for each meatball, I'll subtract the number of meatballs in each plate from the value m. So what does that mean? If somewhere or the other, if the number of meatballs is less than 0, which means we can just say that we are done, we are sufficient. The number of plates would be the answer. So we'll print that. So what we'll do in each, for each element, we subtract the number of meatballs, we increment the number of plates count by 1. If the meatball rate is sufficient, print the value, break. If all this nothing happens, I'm using a for else loop here. If that doesn't satisfy, you will print -1. That's it. So did you guys understand? One more solution. Okay, great. So you want to do the reverse thing. You want to discard the small plates rather than adding the bigger ones. Okay, that's good. It's the same way around. Did you get it, Vignesh? Good. I guess most of them are clear with the solution. Okay, done. So we'll go with the last question from my side. So read this question. It seems to be somewhat tough, but that's very easy. Just go through this question. I'll also paste it in chat. Okay. Go through this for 1 minute. Yeah, 1 minute would be sufficient, and try to answer. Okay. I'm expecting few solutions. Smallest is even place, largest is odd places. Good. Any other solutions? Okay, is there anyone who didn't understand the question? Just raise your hands. I'll explain the question again. So everyone are clear with the question. You're thinking about the solution then. Okay, any other solutions? Or do you agree with Vignesh's solution? Just give me a thumbs up if you agree with Vignesh. Okay. Sort. Sort and add even places and subtract odd places. You mean we'll see this test case here. So suppose if this is the test case 1, 2, 3, you want to sort it. It's already sorted 1, 2, 3. You want to add the even places, which is hello, am I audible? Yeah. You want to add 3 and 1. You want to subtract 2. So that's not the output they are expecting. Sai Charan, are you clear? So suppose if we think like Vignesh, he said smallest in even places, largest in odd places. So what we'll do is we'll put smaller numbers, like if 1, 2, 3 is the input, you need smallest in even and large in odd, like 2 here, 1 here, 3 here. So what will happen? 3 plus 2, which is 5, minus 1, that's 4. So that satisfies the case. Are you good with that? Sum of all numbers, sort, then subtract till n by 2. Sum of all numbers, then you want to sort the whole array and subtract till n by 2. That's great. That's one of the approach. That's correct, Jatin. You need to just take care of even number of elements, I mean the length of the array, if it's even or odd while doing n by 2. Just take care of that. Your solution is right. So if you guys are shy to tell that you didn't understand, I'll just go to the question and give you the solution. Most of you have answered it great. So what we are asking is, yeah, we'll just jump into the question. Here you are given an array where alternating positive and negative signs are there. You can arrange them any of the way you want, so that the sum of the array should be maximum. That's the question. If we look into this question, we'll take this test case as example. So suppose this is the given input. Okay. So what happens? You need to maximize the sum. So what will you do? The positives should be 9, 5, 4, and so on. Okay. And what should be the negatives be? 1, 3, 3. Okay. By which you will get an answer, right? Because you are maximizing the positives, you are minimizing the negatives. So I would say this is you are greedy towards maximizing something. Okay.
ఇప్పుడు వాడు బెంగళూరులో నాకు చెప్పాడు ఆడు వాళ్ళ
Shashank, can you please mute yourself? Okay, great. So you are maximizing something and you are minimizing something. So this is a greedy approach. But what you are doing for that, you want to sort it. What will you do for that? You say something like 1, 1, 3, 4, 5, 9. So what happens here? Till here, you will subtract. Till here, you will add. So this is, I could say, this is a combination of sorting plus greedy. Or the other way around, if you sort it in reverse order, yeah, so that would be your solution. You add all these in your answer and you subtract all these from your answer. So I'll display the solution. Yes. So what I'm doing is I'm taking the input, I'm sorting the given array, and then I'm iterating till n by 2 minus 1 to take care of the indices because it starts from 0. And I'm subtracting all the smaller elements. And after doing halfway around here, I'm adding the other leftover elements. So I guess someone answered similarly. Yeah. Jatin said this, but what he told was we need to add all of them and subtract till n by 2. Instead of that, I'm doing it such a way that we'll subtract till n by 2 and then add all of the remaining elements. So did you guys understand this? Any more doubts? If you understood, just give me a thumbs up. Great. So most of you understood. That's great. Yeah. So these are basic level questions from CodeChef, difficulty of 4 ones. That's good. Okay. So you are able to solve difficulty somewhere near that. How exactly are you implementing greedy algorithm? I didn't get you. Okay, I'll just show that question once again. So what I'm doing, as I said, you want to maximize something. So what does greedy mean? You are greedy about something. You want to maximize something. You are given an array. So what I'm doing, I want to maximize whatever elements are present in the given array. I'll take maximum of them as positive integers and the leftover ones as negative integers. So I'm greedy about something. So greedy doesn't mean always getting maximum. It also means also getting minimum. So I didn't include that question. You can practice them in CodeChef. So in the first question, we saw what we were doing. Yeah, this is the first question. So in the first question, we saw we were minimizing something. What was that? The plates, the number of plate count. We were minimizing the plate count. Here, what we are doing, we want to maximize the summation of the given array. So that should answer it. So are you all ready to solve sorting based questions or greedy or combination of both sorting and greedy? Yes. Great. Done. Good. That's it then. That's for the day. I guess it concludes it. We thought to discuss bit manipulation today, but time isn't sufficient. It's 1-1 already. We'll start bit manipulation tomorrow. So you want to ask any other doubts? Aniket, are you there?
Yeah, Vishwa.
Guys, you have any doubts towards the session, or you want to give any feedback about the session? You want to suggest something to us, like is it fast or slow, or you want it to be more interactive?
Sorry, Andrew question solution to picture.
Andrew question. Okay. So if you have any doubts about the session or any questions discussed in the session or concepts taught in the session, you can message in the group. You can DM anyone. The group would be very good because others could also learn from that. So how's the session? What would be your feedback about the session?
Just any one of you can tell us.
Vishwa,
Chapter.
hello. Does
Hello,
greedy
chapter.
always work with every question అని అడిగాడు ఒకడు DM లో.
No, that's what I was saying about in the PPT. I said about drawbacks of greedy, right? So what did I say? Greedy is like you find the local minima or local maxima rather than finding the global one. So you don't go through all the solutions possible. You just think that this solution might be possible. So you don't think about the global perspective, which will be taught in DP actually. In dynamic programming, where we think about all the possible solutions and you get the optimal answer every time. Each and every time you will get an optimal answer. But in greedy, you are not assured of optimal answer all the time. I
So
guess
there is
you're
no
not.
such mathematical proof every time when we think of a greedy.
Yeah, that's true.
You just go by your gut instincts.
So if when you become familiar with DP, I guess you would be able to compare different approaches, how greedy works, how DP works. So guys, that's the session. We have concluded all of them: bit manipulation,